Perfect. So you should be seeing my slides. Well, thank you for coming to this talk. Um, my name is Leo. I'm going to talk about the Bitextor pipeline. Just to talk some details about myself. I'm a head developer and part-time lecturer at the University of Alicante, more specifically in a research group named Transducence, in which we focus on machine translation and language technologies, also known as natural language processing. I've been involved in Bitextor for the last 4 years, so yeah, more or less since the version 5. And yeah, that's what I'm talking about. What's Bitextor? What can we do with this tool, and what can we obtain from it? So Bitextor is a tool, is a workflow that produces parallel data, or as also we know, parallel corpora in plural, from a website. And by website, I mean domains, given a pair of languages. Okay, why do we do that? Because machine translation systems need a lot of data to be trained. I guess that most of you already know that. And sometimes for certain language pairs or simply languages, there are not that many data, or that much data. So what can we do to obtain data for that languages from an unstructured set of information like is the internet? So that's where Bitextor comes in. In this case, the only information that we need to give Bitextor to produce that kind of parallel corpora is or a list of websites or work files. Work files are the kind of file that is used to archive crawl data. Okay, this is a quite common standard right now. Internet Archive uses it. Lots of crawlers nowadays uses this format for storing that data. But if you take a look to the standard, you will know why. Okay, there's a whole topic about it. Also, you need to provide a language pair, because that's what you expect from a website. Maybe there are more languages, but you don't want to process them. And so you need to provide any kind of bilingual information to Bitextor, so it knows something about the language, and it will then know how to pair a language from a document from one language into the other language. Okay. With that configuration, Bitextor will return pi segments or parallel sentences from those websites. So Bitextor is free open source, GPL v3 licensed. It's mostly implemented in Python and C++, but there's also tools written in Golang, Java, Perl. There are many languages involved there because there are so many small tools that are originally written in those languages. It's been running since 2003, so a long run right now. And yeah, it's available in GitHub. There's the link in case anyone wants to start forking and taking a look. Taking a quite quick about the history. It started as a C++ monolithic implementation, so it was a standalone program that didn't implement any kind of threading or any kind of parallelization, and it ended up as a Unix pipeline in 2010, thanks to the Prompt language engineering people. So it uses, in this version, the Unix pipeline implicit parallelization. So it was quite faster than before. Also, it was modularized, so it was easier to adapt to any kind of weird property a language could have. And by the version 6, University of Alicante, University of Edinburgh, and the Promsit people made the first release for the Paracroll project. In case that you don't know about the Paracroll project, it was a European CF-funded project that its main goal was providing corpora for the official languages in the European Union by doing this process, that downloading data and generating those parallel corpora for those languages. But still, that version had scalability issues. That's why we started Paracroll, because we wanted to be in production level, this size, and we had to rewrite most of the workflow, and we ended up with a SnakeMake. A SnakeMake is a tool written in Python that behaves, as the name can tell you, behaves as make, the GNU make. So yeah, it's quite nice because it's highly scalable. It allows to run your pipelines in the cloud with Azure or Google Cloud or AWS, but also in your local machines like HPCC in the university, or a set of dedicated machines with SSH. So it's super extensible and flexible. Also, it's robust, so if a step breaks, all your previous work is not lost. That's quite nice when you have been running something for a week and you misconfigured something, and yeah, in the previous pipeline based in Unix, the whole work is lost. Also, as it was written in Python, we forced us to migrate all the code to Python 3, so no issues nowadays. And we also added new tools like PDF, data extraction, or support for Microsoft Office formats or Open Document, DocX, PPTX, Excel. So yeah, it started to be a quite nice pipeline by then. And by version 8, we also improved the way that it could be installed, also performance. But the most noticeable thing was that we supported Docker, also Conda and CMake. So the installation couldn't be that difficult, given all the submodules that we have implemented in there. Last release that we did in September included neural-based modules, which is quite interesting nowadays, given all the GPU processing that we have with machine translation. But we are not going to cover this in this talk, because that's a whole long talk after that. Okay, so let me talk about what's going on in the pipeline, so we can understand what we can expect from the configuration and what can we do with this tool. Okay, the tool will look more or less like this. Okay, is simplification of the whole pipeline is receiving a list of domains. It will crawl it, reprocess all that data, and then align the documents, align the segments, and post-process all of that to give us the output, both in TMX format or in TSV format, okay? The tab separated values format. So the first step, which is the crawling, if you're not familiar with this, is just downloading the URLs of a domain by chaining the calls. So if you download one document and it links other documents, you key with that links, and then after you finish crawling that document, start with the other ones, and so on. Okay, there are lots of crawlers nowadays, but I think that the most common ones that can mirror a whole domain or a huge set of URLs are wget, LinguaCrawl, and Heritrix. Wget is the one that I think everybody knows as is the one that you can use in your terminal to download any file like kernel. LinguaCrawl is the one that we developed and is focused on top-level domain crawling, because sometimes in some languages we only have or we expect to only find that kind of data in that language only in its top-level domain. Like, I don't know, is Icelandic, for example. We expect to find lots of data in Icelandic in that top-level domain. And the other one is Hedrix, which is the one that is developed by the Internet Archive people. It's still in active development. It has lots of features like checkpointing, pausing crawling, checking stats. It's a huge crawler, and we also support it, so you can choose whichever you want. After you finish your crawling and storing all that data in work files, as we said at the beginning, or if you didn't crawl anything because you already had work files, I don't know, maybe you have access to some files from the Internet Archive, like we did in Paracrawl, you can start preprocessing. And what's preprocessing? We called it that way because that's what we do before all the heavy processing. In pre-processing, we just fix what is broken at the document level, only with the HTML, and extract all the data that we need. But the data we need is the plain text after we tokenize the HTML. That way is the fastest way to extract all the human readable text for us. With that text, we identify the language. We support both CLD2 and CLD3 for that. By default, we use CLD2 because it can detect chunks of the document in case that it's in different languages. So maybe if our website has 3 languages in it, a web page, sorry, if our web page has 3 languages in it in different paragraphs, for example, CLD2 is able to identify which one is in each language. So that's perfect for us. But we also have CLD3 in case that for your languages it will perform better. No problem with that. We do encoding normalization in case that there's something broken or there's some inconsistencies between the headers and the actual content. And optionally, and that's optional because it's quite expensive in terms of computation, we can perform character encoding fixing using the library Fixtext4U. That's quite a nice library, but it's quite slow. And boilerplate removal in case that you don't want to include like menus in, I don't know, Wikipedia web page that shows your main page, all the languages that is available, that article or whatever is involving the web page, but it's not the actual content of the article. Boilerpipe, which is the tool, will remove all that content. Okay. Don't hesitate to interrupt the chat. I have the chat right here, so okay. If I'm being quite fast in some terms, just ask. Well, right before the document alignment, which is the next step, we do some balancing, because in some cases, when the works can contain several domains, but not all the web pages that are in a domain because there is another work that contain them, we do balancing. We call that shards because we simply get all the works that we are going to process, and we organize all the shards the way that all are more or less the same weight. Because in some cases, if a domain is too big and we have lots of domains that are too small, we can have problems estimating how much time is gonna take all the process. So this way we can at least mix all the small domains with the big ones and be quite sure that the process is not gonna be that much unbalanced. Okay. I just wanted you to know that this is performed here, but for the casual examples that you can use in a server, this shouldn't be a configuration that you should bother. Okay, but we can perform that in Bitextor. We had to, at least on our projects. And right after that, we just do the sentence splitting and tokenization, because that's something that is going to be necessary in the next steps, because sometimes you need the sentences, or you just need the text tokenized. Okay, that's something that we do in natural language processing usually. Okay, so here comes the first heavy step of Bitextor. Okay, the first thing that we do to obtain the actually parallel data is to align the web pages, or I've been already calling them the documents. In this case, what we do is perform one of two strategies. We implemented both, but you have to choose one. It depends on your resources. The first one is a feature extraction with our regressor. Okay, so we obtain a confidence score for each document pair. That way, we can be sure that a document is a translation or is quite similar in a translation than the other. And the other approach that we have is using machine translation and computing TF-IDF. Okay, I will talk about both. Okay, the first one, the based on features and the regressor, uses the first thing that I told in the introduction. This is the bilingual information that we give to Bitextor. In this case, the bilingual information is a bilingual lexicon or a dictionary. Okay, is a dictionary, a translation dictionary. Is I mean a word and the translation of that word, or if there's of two words translated with other two words. Okay, there's a list of that kind of relations between one language and the other. That's the most important feature. So that way we can see which are the word overlapping metrics of two documents. But also we look at the URL in case that the similarity of the URL is high. We can be also quite sure that if the change is just the language identifier that is in a URL, because maybe there's an identifier in the post section in the URL, then we can be also confident that maybe this is a translation of the other web. We take a look at the HTML structure, so if both are similar, also that's a good indication. And the image links, and if those links are related one document with the other, which also is common in a translated documents. Okay, so this regressor obviously needs training data. Okay, we have those uploaded in our repository, but yeah, that's quite fast. I mean, all these kind of features can be run in a CPU with any kind of trouble. They are mostly rules, but again, you need to train something. And some features like the ones I've been talking about need the HTML content stored somewhere. Maybe more cleaned than the content that was originally crawled in work, because maybe there are CSS or there are JavaScript in the middle, and maybe that's too much for this kind of features. So you need to also process the HTML to clean that information from the HTML. On the other hand, we have the machine translation system. Okay, this is the other approach. So we translate the text in the language 1 or the source language into language 2. That means that we need to translate everything from the language 1 into language 2. And after that, we just calculate the monolingual TF-IDF. As we have translated documents, we only have to check that the documents that we already translated are similar than the originally target language that we already have. Okay, so yeah, in case that someone doesn't know about the TF-IDF, the TF-IDF only take a look at the relevant words that are frequent in a document, but infrequent in the whole set of documents. So a document is specific talking about something. Okay. This way, there is no training data involved, because you just need to give a system that translates, and you don't need HTML. Only with the plain data you can work. So more free space in your disk. But obviously the disadvantage is that you need to translate everything, and you need a machine translation system, which usually involves lots of resources like GPU, memory, or time. Okay, um, yeah, both systems are useful in different situations with some languages. Okay, but after doing one of the two approaches, we get the segment alignment step. In this case, we already have one document in the source language and one document in the target language. But we need to align the sentences in those pair of documents. How do we do that? How do we do that? Is simply using one of the two tools that we support that are handline and blealign. Handline is based on dictionaries, like the dictionaries that we use in the document alignment step. So that's the usual case. So you use the document alignment. So the dictionary document alignment step with the dictionary sentence alignment based on handline. And if you use the document alignment based on machine translation, you use blealign, which is the one that uses. In fact, you can use the combination that you want, as SnakeMake is flexible enough, but obviously you will take a lot of time to process it if you mix machine translation with dictionaries. Okay. Okay, so at right here we will discard it. We will have lots of documents and sentences discarded as those documents and sentences that haven't been aligned are not necessary anymore. So we don't need them. More or less, it's the 10% of the actual content that we crawled. So at this point, it's just fast, and we only want to get the best sentences that we can from this and onwards. How do we do that? Just repairing the text and marking duplicates with Bitextor, which is a nice tool. For example, it fixes emoji buckets and some encoding issues. It also detects the duplicates by deleting some characters that are necessary for the actual content, like the stops or commas or slashes or dashes. So if there are two sentences that are exactly the same without those characters, they can mark them as near duplicates, and you are able to filter that if you want. Also, we have Bycleaner, which filters the noisy sentences. Okay. In this case, Bycleaner, what it does is something like a human will do without knowing the languages he's checking, but looking at things like if the length of one language is very long and the target language is so short, that's not a sign of a well-aligned sentence. So Bycleaner uses rules like these ones, or maybe taking a look at the amount of numbers in both sides. If one side has 6 numbers and the other side has none, that's not a good sentence alignment too. Bycleaner uses that kind of rules and machine learning systems to give a score, so you can be also more confident that the sentences that get out of that are nice. Okay. Also, optionally, we have roaming. Roaming is random omit, anonymize, and mix in case that you have troubles with copyright and personal data or things like that. So by roaming is created with that finality, and we have the duplication. Okay, in case that at this point we have still duplicated. And at the end, we generate the TMX if you want to have that format, and otherwise we will generate the usual format, which is tab separated value format. Okay. So now that we know about Bitextor, how do we use Docker with Bitextor? Well, from the development side, we simply use Docker with the auto-boot feature to check that everything is all right. At each commit that we do at the main branch, Docker auto build creates a build with the Docker file, and it does the simple checks that is not broken at compiling everything, and running the basic checks. Okay, simply as that, because that's already a huge amount of time. And of course, if there is an error, we will get a notification both in Docker and in GitHub. But on the releases, other than the tests that we perform on GitHub Actions, we will also download from GitHub Actions the build that Docker gets built, and then run tests both on the local installation that we have on GitHub Actions and on the Docker container. So we check that everything gets correct with our unit tests and the integration tests, and both results are the same. Okay. So that's a huge work for us. It helps a lot when we are developing crucial changes, because that way we are not sure that something is messed up with all this huge process that we have. But for the users, obviously it helps us installing it, because Bitextor, as you can guess, it needs lots of dependencies. And if you have a machine translation system that needs GPUs, and if you have any kind of tool that you want to use for tokenizing, or all of that, it's usually too complicated to mix with the already complicated setup of CLT3 or the Java dependencies. So all of that is managed on the builds on Docker. So you only need to pull and run. That's perfect. Okay, it's easy, and if we have time, we can take a look to a simple example, so you can see and follow if you're interested on see it in action. Okay. All this data is public available, so this is not a fake demo or something like that. Okay, the data I'm gonna use is right here in the Bitextor data repository, and I'm gonna use a biclean model that is the one that we use in Paracolor. And if you need more documentation about the extraction and using in Docker, we have a wiki in GitHub, so you can check all the options that we set up there. I have a basic configuration file, because the file is a YAML. And if those configurations are too basic for you, we have a config MD documenting all the available options that we have in Bitextor, so you can just play around and test an object that could fit for units. Okay, let's see how it works. Yeah, I already set up a dedicated server with Ubuntu. It should have Docker. Okay, let's create a Bitextor data where we are gonna store all the data we are gonna need. First of all, let's take a look at the works. Okay, we crawled some time ago these 3 domains, which are Creative Commons, so we don't have any license issues. And that's the test that we have for the automatic testing. I already made a Greenpeace.Canada a small version for a short test, but still is a bit too large for this presentation. So I made a very small, is 3 megabytes. Okay. I download it. I do the same with the dictionaries. Okay, we have dictionaries already trained here from long time ago. We are gonna do English, French. Okay, copy link. Oh, sorry. Okay. And finally, we will download the bicleaner model. We will use again English, French. wget. This is a bit big, but okay. All right, we have all the data in our folder. Let's uncompress it. No, this no. Okay, this one. Okay, this is the data that is in the biclinar model. It even has upon removal, the models that that will be scoring the biclinar score. And that's all the data we need. That's everything, okay? If we take a look at the documentation, we have simply the command that we need to use is docker run, and obviously to provide this data to the container, we will need to create a volume, okay? I think I already have the command. Yeah, but before that, yeah, this is the command that we are going to use. But before that, we need to provide Bitextor a configuration file. Let's create one. Okay, we will run Bitextor this way, and if we take a look at the example I have in the repository, okay, these are some basic variables that you can test on your desktop without any issues. These are the folders that we are going to use to store the data. This is the pre-processing data, the output data, the intermediate data that we call transient because that's kind of temporary, but still is needed for SnakeMake, and temporary dir, which is the actually temp dir, but we are going to use the volume folder, so we don't have any disk space issue. Okay, we set here the work file that we are going to use, but if you don't say the works and you say hosts, you can write any domain that you want, and it will crawl. Okay, I think the default crawler is wget, so if you don't set any other setting, it will run wget. Okay, we will run preprocessing step with these settings. This is the preprocessor by default, but this is written right here, word to text. Sharding, we will run 0 shards, and we will make 1 GB split. In this case, we're not going to reach it. So yeah, again, this will not make any change to our processing. Obviously, we need to, as we said, give the language pair. Language 1 is English, language 2 is French. Which dictionary, which document aligner are we going to use? We are going to use the dictionary based, and which dictionary is the one that we are going to provide to use as a seed for the words that is going to be compared between the documents. And that's it. The other settings are the sentence alignment, which is HANAlign, and we are going to use Bifixer, Biclina, where is the Biclina model, which is the threshold. I put 0.7 because it's the one that Biclina says that better compromise between amount of data and quality. Because if we reach it goes from 0 to 1, maybe with 1 we get to few sentences at the end. But yeah, they recommend between 0.5, 0.7. Okay. We are not going to use the roamer as we want to understand everything that goes out. And let's dedupe and get the TMX, okay? Just for the sake of completion with the explanation that I made. Okay, so let's download this configuration file. wget. Okay, everything is here. Sorry, I wanted to use, okay, that's quite better. Yeah, this is just for me to not get lost on the terminal. Okay, right. This is in the middle. Right. I need to use sudo because I install Docker with snap, so otherwise it won't have permission to run on this machine. Okay, that's the only thing that you need to know about that. And I think that's it. That's Docker run with the volume, which is my home, Bitextor data, which is all the folder that we use to store all the data, and it will mount on home Docker host data in the container. Okay, this is the image that we are going to use, and the configuration file, it's this one. Okay, I put 52 threads because I think that this server is being used by more people, and I don't want to bother them with this. Okay, okay, let's see how it works. Okay, my password. Okay, we'll start. This is a snakemake, outputting everything. As you can see, snakemake shows the daytime of the job, how many steps are still pending. It will also internally create a tag which will make the dependencies of the jobs. So if it can run several jobs at the same time because they don't have any dependencies on inputs and outputs, it will do it. And also if it has enough resources, obviously. Okay. So let me recap a bit about the output it is doing. Yeah, see all the jobs that it is gonna do. It just run the word to text, which is the preprocessing step, sharding, which are simply input and output because it's not processing anything. Initializing shard 0, that's nothing. It will split the sentences, as we said, for source and target, okay, French and English. It checks that the underlying dictionary is already given to Bitextor. Otherwise, it can create one. Okay, that's something that you can check on the documentation of Bitextor. It will tokenize. It will mix all the tokens in case that we have several shards. In this case, we don't. And it will start right now doing the document alignment information. Okay, you will get the indexes of the documents and start getting the features. Okay, the image overlap for both languages, the structure distance in the HTML, the URL distance. Okay, so it creates all the features, URLs, as we were talking before, and then it will rank and get the score for the whole set of documents. After that, well, in this case, it was still missing one feature from the other side. Yeah, after all the ranking is done, it will actually align the documents. You will check all the alignments and the scores and say, okay, this document is really the alignment of this one and not the other ones, because that's the best score that we have for this document and all this set of documents. And once we have the matches, okay, which document goes with the other document, we'll then run handline. And that's it. Once handline is done, that's the split second line because it can be performed in multi-process parallelization. It will run by fixer, by cleaner, filtering in case that we want to filter. That's the case. We are filtering by 0.7. And that's it. We get the sentences, the dedupe, TMX, on the TMX, and yeah, that's it. It ended up quite fast. Let's take a look at the data that it outputted. It will be impermanent because it's the permanent data we don't want to lose. And there's lots of files here. They are the different formats. Okay, this is the dupe. So there are no duplicate sentences in the TMX format, the TXT format, or if you are not deduping or we don't want the deduping one, we also have the TMX and the sentences, which is the same as the TXT without deduping. Okay. Yeah, let's take a look. So we are sure that everything is okay here. So okay, on each line we have several columns, as we say, separated by tab, which is the URL. This is the URL for English. This is the URL for French, and this is the sentence in English, and this is the one in French. Okay, this is the score for the document alignment, and this is the hash for Bifixa. So this is the one that he looks in case that he's deduplicated. This is the score also in case that two sentences are quite similar, which has better score because it's better formatted than the other similar. Then this is the score of by Cleaner. Okay. But as you can see, I don't know any French, so I mean I know Spanish, but that's anything that's the only thing I can say about identifying if a sentence is okay or not in this case. He's talking about antique and vintage shops, flea markets or bazaars, used bookstores, second-hand shops, okay, and gold mines. In French, antiquaires, which is vintage shops, bazaars, and ligne. In this case, this is not talking about shops online, but even in this case, he's aligning it, so that's great. This is between brackets, which is this too. I don't really know what this means, but yeah, this seems okay. And are gold mines and this mines door. I will say that this is the same concept. Okay, so even in French, which has the enumeration of places, I guess, in the different order than the English one, it was able to align it. So yeah, that could happen sometimes. The human is translating a document and it mixes orders, or just is more free when he's translating because it's more natural for him. I don't know, but even in those cases, this is able to do it. Let me delete the URLs, or maybe I can even. Yeah, I mean, yeah, the URL is still working. So we got from these two pages, which are, I mean, rich and has CSS, and they will have JavaScript that they have buttons and images, and we were able to extract the actual content that we want and align those sentences. Okay, in this case, yeah, take a look. Okay, so this tool is very interesting. So because in massive amounts of data like the Internet Archive, this is the only way to do it. We need to process it, and machine learning will get this information. Let me. I think I can. Yeah, I had this comment before. Yeah, I don't need the other columns right now. Okay, so yeah, it looks okay. The same way that, for example, this sentence doesn't have, for example, this acronym, but it looks okay because, for example, the number is exactly the same. He's talking about grouped experts, which is talking about a recent report about governmental people in the climate change. So yeah, it's quite good. I mean, it's not the best translation in terms of human, but from this website, this is nailed. I mean, we cannot get a better alignment, and that's very interesting that even in this different sentences, even in the structure, is able to align it. Okay, yeah, it seems great. This acronym is different than that one, and it's able to recognize it. Yeah, that's it. That's Bitextor. That's what we do. And with this text, you can train your systems with new vocabulary. For example, with new pandemic vocabulary that any other corporate doesn't have, or any specific kind of terminology that your company uses because you have manuals in different languages, or that's something that you can use to train your system. Okay, that will be it. Any questions, please write in the chat, and I will try to answer them. I stopped sharing screen. Sorry. Yeah, that's last. Hey. Okay. I will be in the next 5 minutes answering questions if there is no issue.